Here is question 5 of our quiz on quadratic functions. It says determine the number of real zeros for given functions. Function 1 is given in standard form. F of x is x squared minus 2x minus 3. I'd like you to make a note of all these questions, right? And then answer these questions. And stop the video. I'll try to give you the answers. After that, once you have done your work, then check your answers. Part B is g of x equals to x squared plus 1. C is h of x equals to 2 times x plus 1 whole square. And D is m of x equals to x times x plus 1. So these are 4 different parts of question number 5, and you have to determine the number of real zeros. Okay. Now let's go through them one by one. The first one, if you have an equation in standard form, the best way to find number of real zeros is to check discriminant. You know the discriminant? It is like square root of b squared minus 4ac, right? You need to check this value. If it is positive, then there are 2 real zeros. If it is negative, then no real zeros. And if it is 0, then we have 1 real zero, right? Okay. Now that 1 real zero actually gives you two roots at the same point, okay? And when we say it is positive and 2 real zeros, we mean 2 distinct roots, 2 different separate roots, okay? Now here, what is b for you? B is minus 2. So let's calculate. Minus 2 square minus 4 times a is 1, and c is minus 3 square root, correct? That leads to minus 2 square is 4. This minus and minus becomes plus, right? And 4 times 3 is 12 and square root. So we have something positive inside the square root, correct? Okay, so if we have something positive here, that means we have 2 zeros, correct? So we can write down our answer as the number of roots are 2 distinct zeros, right? Correct? They are 2 separate zeros, right? Because if you see, the whole formula is minus b plus minus b squared minus 4ac divided by 2a, right? So you get 2 different zeros. Correct. Now this one here is g of x equals to x squared plus 1. You could follow this method also. So what is b here? B is 0, okay? And for a is 1, c is 1. You could do this, or you can use your knowledge of functions. The sketch which you have learned, it is x squared plus 1, right? So if you transform x squared is like this, which goes through 0. Plus 1, it moves 1 unit up, right? So if it moves 1 unit up, let's say this is 1, then it doesn't really cross the x-axis, correct? And therefore, it does not have any real zero, okay? So we say no real zero. Okay, let's look into this one. Can you sketch this function? H of x equals to 2 times x plus 1 whole square. It really means that you have moved your x square 1 unit to left and vertically stretched by 2. So basically your function is kind of like this. So this point is minus 1. The vertex is at minus 1, 0, right? So what you have here is 1, 0, right? And there are double 0. Why? The degree is 2. Do you see that? So we have actually number of zeros are 2 here, and both are at one place, right? So here we have, we'll call 1 real zero. We will say 1 real zero of degree 2. Do you understand degree 2? Or we should say multiplicity 2. Degree or multiplicity. we could use both the terms, okay? Or in general we say of order 2. Degree, you'll get confused with the degree of the equation. So we use multiplicity or order. So you see the multiplicity of order is 2. The 0 is kind of different. It turns from that point. Do you see that? So we have one real 0. And the 0 is at -1. But its multiplicity or order is 2. Okay. Now the last one is m of x equals to x times x plus 1. So this is given in the factored form. Here you can see zeros are at x equals to 0 and x equals to -1. So your function will be kind of like this. Is it okay? Where the zeros are at -1 and at 0, right? And so we have two real zeros. Is that okay? What is the order of each? Of order 1. Multiplicity is 1, right? So that is how you get number of real zeros. So you could use the discriminant or transformation, right? Or your knowledge of the equations, intercepts, correct? Depending on in which form the equation is given. Okay, thank you.